Warm welcome to your grade 12s. In front of you is Buko. Welcome back to our channel. So today we're going to be looking at maths grade 12 and the topic sequences and series. Alright, so specifically we're going to be looking at geometric sequences, a new thing in grade 12. Remember grade 12 that in your grade 10 you've discussed arithmetic sequences, and more especially in your grade 11 arithmetic sequences or linear sequences with quadratic sequences. But now in grade 12 so we introduce you to geometric sequences. To geometric sequences. Okay? Alright. That's it. Alright. So let me define for you geometric sequences. In order or in a sequence, this will be in order for you to get the next following term in a sequence. The next following term, we multiply by the common ratio to get the next following term. Simple. Whereas in an arithmetic sequence, we add with the common ratio. But now it's a new thing. We multiply. It's underline multiply in geometric sequence. So in geometric sequence, we multiply by a common ratio to get the next following term. Simple. So let me also introduce you to the nth row of a geometric sequence. So the nth row of a geometric sequence is Tn is equal to a r to the power of n minus 1, and that's it. Simple and straightforward. So look, so let me break it down for you. So our Tn there, our Tn stands for the term in the sequence. The term in the sequence, okay? Yes, stands for the term in the sequence. Let me also illustrate as an example of a sequence in a side wave form. Okay, let's say we have 2, we have 4, we have 8, we have 16. And this is a geometric sequence, as you can see. Because in order for us to get the next following term, we multiply by 2, which is the common ratio. For example, in order for us to get 4, we multiply by 2. In order for us to get 8, multiply 4 times 2, 8 times 2, 16. Okay? Yes. Multiply by 2 in order for us to get the next one term. Tn, the whole thing is a term. Okay? This is a term. The term in the sequence, for example, 2 might be the term in the sequence, 4 is the term in the sequence, 8 is the term in the sequence, and 16 is the term in the sequence. Alright? So we also have n underneath there, the small letter n. The small letter n stands for the nth term in the sequence. For example, if we substitute 1 there, we are going to have term number 1 in the sequence. Our term number 1 is equal to 2. Our term number 4 is equal to 16, for example. So that's it. Also, if this n changes, also that n changes. Let's go to a. You know that we talk that in most cases, when we are dealing with a, also in your previous experience with the types of sequences that you have dealt with, so a is the very first term of the sequence. Or is the first term of the sequence, not the very first, it's the first term of the sequence. First term of the sequence, okay? And r is a common ratio. R is a common ratio, okay? So look, R is a common ratio. In order for us to get a common ratio in other forms, this is why we are going to divide the number that is ahead or the term that is ahead with the number that is behind. For example, T2 divided by T1 is going to give us R, which is the common ratio. T3 divided by T2, the number that is in front divided by the number that is behind. The number that is ahead divided by that is behind. For example, let's say T3 divided by T2. T3 is 8 divided by is equal to 8 divided by 4, which is equal to the common ratio 2, which is also the same as equals to the common ratio is equals to 2 when multiplying. So in a reverse way, this will by we are dividing, but when we are moving forward, we multiply to get the next following term. That's it. Please don't forget that technique. Alright, so R is a common ratio. So n, very same thing as that n. So n minus 1. Alright, so Tn is equal to AR to the power of n minus 1. Mind you that A is colliding with n, is right next to n. There's no sign in between. So mean that when you know that when two variables are in contact or they're just right next to each other with no minus or plus, so mean that you know that they are multiplying, alright? Alright. Look, grade 12s. Now, let me make an example of creating the nth rule of this particular geometric pattern that I've made an example of. Alright, so we have 2, 4, 6, 16. 2, 4, 8, 16, so sorry. Alright, so look, we have Tn is equal to AR to the power of n minus 1. So our Tn will be equal to A. What's our A? A is the very first term of the sequence, equals to 2 multiplied by R. Our R is the common ratio. Our common ratio there is 2. And in order for us to get the next common term, we have to multiply by 2 to the power of n minus 1. And that's it. Simple and straightforward. And that's our general rule or our nth rule of that geometric sequence. Okay? That particular sequence. So you might use your sequence in order to get the terms that are being asked during your exam or your test, whatever the case may be. Look, right now let's clarify or let's make it sure that or let's just test if our nth rule is correct by calculating the third term of the sequence, T3, term number 3. Our term number 3 is 1, 2, 3 is equal to 8. Let's check. So we have Tn is equal to 2 multiplied by 2 to the power of n minus 1. So our term number 3 is equal to 2 multiplied by 2 to the power of 3 minus 1. So and therefore our T3 will be equal to 2 multiplied by 2 to the power of 2. 3 minus 1 is 2, right? Yes. And therefore, okay, therefore we're supposed to be at this particular point. So sorry. So T3 is equal to 2 multiplied by 2. So 2 multiplied by 2 is equal to 8. And that's it. We get our 8 in that kind of a way. So that's our geometric sequence. If you have any question, or you can just comment on the comment section below. Thank you so much. Have a great day. Cheers.